All right. Hey, what's up? Another day, another Leetcode problem. Uh, Today we're going to try to solve the problem called lucky numbers. All right. I solved this with a moderately fast but not very spacious solution. So let's take a look as I code it up on how we would go about solving this. This is a matrix problem. Um, Typically, matrix problems aren't my favorite Leetcode problems, but um, hey, what can you do? Matrix problems show up everywhere. They're in interviews. They're in um, uh, I don't know, just about any kind of real life coding situation. You have two-dimensional arrays you want to deal with all the time, right? So we want to be able to manipulate matrices and do algorithms on matrices. So another interesting thing with matrices is that uh, there are often ways, there are often optimizations that you can do. The problems are written in such a way that you can there are optimizations that are clever that can be done based on the order of numbers in the matrix or the matrices, and I'm pretty sure that this is one of those problems. However, I'm not going to do an optimal solution. I'm just going to do a functional solution because I just want to go about a small optimization on how you could think about using sets. Okay, so lucky numbers in a matrix given a m by n matrix of distinct numbers return all lucky numbers in the matrix in any order. A lucky number is an element of the matrix such that it is the minimum element in its row and the maximum in its column. Okay, so basically minimum in its row and maximum in its column. So if you look at this matrix here, 3, 7, 8, 9, 11, 13, 15, 16, 17, there's only one lucky number here. It's the minimum in its row, right? This is the row of 15, 16, 17, the third row. And it's the maximum in its column. 3, 9, 15 is the column, right? So it's going to be the maximum there, right? So therefore it is a lucky number by the definition of lucky numbers. Who even knows if this is a real mathematical concept, other than for fictitiously created for coding problems, but still interesting still interesting problem to solve, and let's get to it. So first thing we want to do, and this is a minor point and actually generally language agnostic, but we want to try to make sure we're not iterating unless we're not creating excessive computation when iterating. So m and n. So m is the number of elements in each row, and n is the number of elements in each column. They're different, right? So first thing we want to do, matrix length of matrix, right? And then if you want to get the length of the matrix, or the height of the matrix, whatever, the span, whatever you want to call it, we extract these variables. So what we can do there is now we want to, first thing I like to do with these problems is just, even if I'm just like sticking to the brute force method or trying to come up, if I feel like I know the optimal solution at some point, I still want to just try to get the iteration down, right? First thing you want to do is for n, let's try for a row in range 0 to m, right? And for col in range 0 to n, we want to, now what do we want to do? We want to essentially maintain, we want to get the, like conceptually speaking, there's two iterations here, right? So the first iteration we want to do is the minimum. We want to find the row minimum, right? Because we need to have the row minimum and maximum both equal to something, right? And we're comparing those values. So the minimum, first we start with setting the minimum equal to the largest possible value represented in a number. in Python, right? Because anything, we start with the highest value, and then anything less than that, that'll be the initial value for the minimum. Then anything less than that will be a true minimum, right? Or a true local minimum, less than the already computed minimum. So what we can do is if min, if actually let's try, if matrix row col is less than min, okay, we say min is equal to matrix row call. Now, we could do this with the minimum function. I just want to print this out to make it clear. So what we're doing in each case is we're just detecting the row minimum, right? So what we want to do is we want to keep track of these row minimums. So I'm creating a new set called mins. Now you might be asking, why am I creating a set? I'll show you in a second. So I add min. Now again, I'm trying to brute force this one for understanding, or not brute force it. I'm trying to elucidate the process a little more clearly for understanding. So for row, now we're going to look at the columns, right? So for col in range 0 to n, max. Now what is max going to be? Well, max, I'm setting it to 0, and I'll show you why. If you look at the minimum value of the matrix, any value within the matrix is between 1 and 10 to the 5th, right? Okay, in fact, this could have been set as the initial minimum, but it's all right. And it's between 1 and 10 to the 5th. Okay, so 1 in 10,000. So basically the max, I'm going to say, is going to be 0, okay? Because that's good initial value, because since there's nothing that can be as small as that maximum, so anything larger than that detected will be a true maximum. Okay. For row in range 0 to m, okay, now we're looking through the rows. Remember, we're iterating row and column, right? So if matrix row column is less than max equals. Now I might be tempted to do this, right? But remember, also the other thing I want to do is I have a set of results that I need to return in the form of an array, which list here array, right? That would serve as my final answer. So what I'm going to do is going to write that here before I go into the core part of this return result. Now, here's the thing you want to keep in mind, right? Okay. Now, if I were to just keep track of the max value, right? Another set of max values, then I'd have to go through another loop in order to iterate through there and compare each min value and see whether it existed for each max. So this is the small optimization I was talking about. I'm going to say if max in mins return result dot append max. Okay, so now that is going to be the lucky number, right? And I'll show you why in a second. Let's just see if this works. Okay, let's see. What did I do wrong? If max in mins result dot append, no, max. This is what we have to do. Nope. And no, we don't want to do it here. We want to just set the max at the end, and we want to check this condition here. All right, that's what I wanted to do. Okay, so max equals if is less than, and I'm going to do like this. Okay, I believe this should work. Yes, there we go. Okay, now let me explain what I redid, right? So this is the row minimum, okay? I'm collecting all the row minimums, and we want to find out whether a number is both a row minimum and a column maximum. So since we have all the row minimums, we have the column maximum here, right? Now we have to find out if the row minimum, if the column maximum is contained within the set of row minimums. And this is a quick O of 1 check here. O of 1, okay? Because that's how long it takes to look through a set, right? So that's basically it. And then let's try submitting it again. And as we can see, faster than 58.73 that run, okay, and still not very space friendly, like pretty low, but you know it's okay fast speed wise. And the reason was for this optimization. If we instead iterated through this array here, like if you wanted to do the comparison of each max within all the detected mins, then that would be another iteration we'd have to do, and that would increase the increase in overall time complexity, right? So anyway, not the fastest, but still proved my point. And that's it for solutions today. I hope you enjoyed this video. I'll do another one tomorrow. And if you like this video, don't forget to like, subscribe, and do all those good things that YouTube people do, share, etc. You know, and I'll make more, whatever. And I hope you learned something from this. Okay, and also for you algorithmically gifted people out there, don't worry, we'll get there. All right, this is just interim in my video journey. So I'll see you guys later. Bye.